Hi, my name is Ben House, and I'm in the Computer Science Independent Certification class at Gull Lake High School. And today I wanted to give an overview of everything that I've learned so far in my certification that I've been getting. This is my IT Specialist Artificial Intelligence certification. This is a course that I've been working through. I am nearing the end of this course, as you can see here. I'm currently working through lesson 10 of 10, and then hopefully in the coming week or so I'll move on to the practice test and then hopefully get certified. As you can see here, I am 89% of the way through the course. This course has taken me through just all different aspects of AI, like from everything from like what AI is and like the fundamentals of AI to making your own AI project. Um, So it's done things like defining the problem for AI, making sure that the problem that your project presents is usable for AI, accessing and managing data for AI, so like finding data that is usable, suitable for your project. Lesson 4 was about analyzing data, about kind of like cleaning up your data, making sure that there's nothing that will cause your model to like kind of veer away from what your intentions are. And then designing a machine learning approach, which was about making sure that your project um, allows for AI or machine learning to be used with it, and how to make sure that your problem um, kind of is geared towards what machine learning can help you with. Lesson 6 was developing classification models. Lesson 6, 7, and 8 were all about different sort of machine learning models that you can use. This was about classification models, the next one was about regression models, the next one was about clustering models. I'll go into a bit more depth when I go over my notes. Um, and this one right here was launching an AI or a machine learning project. It went over a lot of like how you would do that through like a business perspective, like how you would get permission, how you would get data, how you would like ask all these things, and just like the process of going through that, what it would look like, and like presenting your results to people. And then lesson 10 is one that I'm currently working through. I'm currently in this communicate model capabilities and limitations section. These last two lessons are more about the process of making a model for like a company or business, or for like any sort of work, rather than how AI itself works, which I think is pretty cool. Next, I want to take you over to my notes. This is my engineering notebook for my certifications that I worked through. I have my uh, first certification here, my certified entry-level Python programmer notes here, and then this is the one I'm currently working on. Take you through lesson 1. Lesson 1 again was about fundamentals of AI. It talks about like what AI is, how it's machine learning, a machine basically exhibiting human-like intelligence. Um, Explains things like, again, AI, about things like machine learning, how um, it goes over this topic about like deep learning. Um, the course doesn't talk about that too much other than this mention, but it's so good to know about. It explains how search engines work, and just goes over a bunch of basic terms that will be really helpful to know going throughout the course. And then at the bottom of all of my pages for notes, I always have additional research. That's another thing that I really like about this course, is that it gives you links to websites um, that allow you to do further research. So if I need to know more about a certain topic, I can go to one of these links and it'll give me a website with more information on the topic, which is really amazing that they did. I'll take you here to lesson 2. This is about defining the problem for AI, how to make sure that like you're thinking in a way that can be used for AI, and that you're um, sort of a little bit of ethics for AI, how to make sure that you use AI for a good thing, Um, it goes over, sort of the risks of AI and machine learning, ways to mitigate those risks, um, different things like the scope of your project, which is pretty much like looking at all of the things that you will need to make your project work, pretty much, which is good to just have like an outline of your project. And yeah, things like that, certain tools you can use for AI, and then again, my additional research. So here's my lesson 3, um, assessing and managing data for AI, which is again about finding data. It tells you about different types of data, like big data, open data sets, stuff like that. It goes over different types, like quantitative, qualitative, ordinal. It goes through the data cleaning process, which is pretty much just preparation for using in training your AI model. It goes through like how you can turn images into sort of like numbers or like data that your program can actually understand, can actually make results from. And then lesson 4 about analyzing that data, pretty much how to read that data, and how to make sure that everything is again a way that's readable. Um, Feature relevance, make sure that everything's relevant. Make sure that your population samples, it goes over like the differences between the population, which is like a whole entire group of people, and a sample is like a section of that entire group. It's often hard to get full population because it'll be like such a big number, while sample is like smaller, and it's a lot easier to get data from. It's important to look at like imbalance of data sets to make sure that your data is not like skewed a certain way. It's important to look at like distributions. Again, this section had a lot of images, which really helped as well, which I dragged over here. I'm a very visual learner, so these charts and graphs and everything helped a lot. Talks about the different sort of distributions, like normal distribution, non-normal distributions, like this. Talked about things like central tendency, and yeah, it also went into some topics such as variance and standard deviation, which required some formulas that they showed us and they explained. And then talked about being skewed a bit and how like it can be skewed left, right, or just be normal. I also talked about kurtosis, I think is how you say it. But pretty much just how big the tail is. So the tail would be like this little slope right here, so you can see on either end. These are heavy tails, normal tails, and then these are light tails because they're just small little curves. But yeah, it also showed a lot of different ways that you can you can visualize the data, like histograms, box plots, violin plots, scatter plots, line plot, and many, many others. Lesson 5, we moved on to designing a machine learning approach. It explained things like bias and variance, and making sure that your machine learning process is like fit well to your data. Obviously, you don't want it underfit, or else it will be very inaccurate, or you don't want it overfit, because then it will be like it'll try to fit your data or like your question into something that's not supposed to be, pretty much. It'll try too hard, if that makes sense. It goes over like how to find a sweet spot between those two, between variance and bias. Talks about different methods to do that, different methods of training that might help to minimize underfitting or overfitting. And then lesson 6 talked about developing classification models. So this is the first of the 3 different model types that I learned about. So in this one was classification models, which is basically separating your results into 2 different categories. So it'll be either like yes or no, or it does exist or doesn't exist, or a 1 or 0 pretty much. So you'll see on like this logistic regression model, it'll draw basically a line, which I think it shows down here. Yeah, it'll draw a line through the data, where if you're either on this side of the line, it'll be a no. If you're on this side of the line, it'll be a yes. It gives you equations for stuff like that. And then it talks about how you can get more than one result out of these, but you have to use multiple of the same sort of model. So you can use like 2 of these to find like a no, yes, yes, no. It's a bit complicated, but they explain it well in the course. They talk about things like here, which is the k-nearest neighbor thing, which was a pretty much graphing it and seeing how close it is to each, and if it's sort of equidistance, see which one it's closer to more. So the k and the k-nearest neighbor one is like the number of neighbors it'll look at. So here k would be 3. So it looks at its 3 closest neighbors and figures out which class each one is in, and whichever one has the most, it will classify that example in that group, in that class. And as you like change the k, it can get different results and stuff like that. So this one's 5, and it goes from being in the classification of 0 with 3 to a classification of 1 when it has 5. Support vector machines, it's a bit more complicated, pretty much drawing a line between groups or classes and how to make sure that line is put in an accurate spot. Naive Bayes classification, which was a more mathematical way of doing it, pretty much how to use that equation. Decision trees, which are a very simplistic and very visual way of using these models, which is why I liked it, because it's very visual. Again, I like being able to like see things and know how they work. So it pretty much just asks like a series of yes or no questions that go to one result or another. So I think this example is talking about if people who played a game would recommend it or not. So it pretty much said if the player rating was greater than 4, if no, they would not recommend it. If yes, they would recommend. Not if yes, they would recommend it. If yes, you would ask this other question. If their playtime is greater than 100 minutes. If it was, they would recommend it. If not, it would ask this question, and then so on and so forth. Another reason why I thought decision trees were cool was because if you come down here, you can use multiple of them, and when you put a bunch of decision trees together, it's called a random forest, which is really cool. And then it goes over another thing about like how you can use matrix to kind of assess how well the classification models worked, to make sure that they're giving you data that's accurate, because that's pretty important depending on what your machine learning model is. Obviously, you always want your model to be accurate, but it is more important in different aspects than others. Like in this example that the training course gave was like if you're using machine learning to diagnose like a disease or an illness like cancer, it's important more that you have like less false negatives. Not false negatives. Oh yeah, false negatives. Sorry, my wording. It's not as important if you have less false positives. That's okay. But what's important, it explains how like what's important in this sort of example is that you have both the machine learning and both the human testing aspect of it. which is good to learn. You want to maximize the true negatives and the true positives. So these numbers as low as possible, these numbers as high as possible. Um, and then you go through different ways to test the accuracy, and then how each of them. Are these the same? No, they're not. They look very similar, but they're not. I promise. It goes through different ways that you can like mitigate different, like how to mitigate false negatives, how to mitigate false positives, in training model. It's not training model, an assessment, a way to assess your model that is kind of the best of both worlds. And then lesson 7 is another type of model, which is developing a regression model. So it's pretty much graphing, and given the x, you will get y. It's really useful for like prediction. So yeah, it will pretty much you'll pretty much plot all of your data on a graph, and then you'll find the line of best fit. And then again, from there, you can use an x and y to predict an outcome. Yeah, it's good for forecasting, trying to figure out what will happen in the future, like telling if the graph will move up or down, or what your data might do in the future. I went over like finding a good line and how to find the line of best fit. And then I went over how to evaluate your regression models to make sure that that line of best fit is the line of best fit. Different ways to do that, like mean square error or mean absolute error, two very similar ones, but they're both good in their own ways. And then coefficient of determination, was one that they explained is in ways better than the other two, but in ways also worse than them. It's good to kind of assess your model in multiple ways if you can, because then you'll be able to kind of compare your results and make the best assessment off of them. And then this third type of model that I learned about was a cluster model, which is pretty much just finding, kind of like grouping stuff together. It's kind of like that example that I had from the classification model, where you're kind of like grouping them together, except instead of basing it based off of how close it is to other data points, it's basing it off of how close it is to the center of a group. So pretty much you'll have a point on the graph, and whichever point that data example is closer to, it will be considered part of that group. And the center of the group is, I think, it's called a centroid. So if like this data point is closer to this centroid, so it'll be considered part of that one. It goes over things like how to find the best spot for your centroid, and how to like reassess where the centroid should be depending on where your data is. How to find the right number of centroids that you want, which is pretty much this right here, this elbow point, where the more centroids you add, like stops substantially decreasing the average distance that the data points have from the centroid. It talked about some ways to analyze how well your model is, and again, to just kind of mitigate the amount of error as much as possible. And then we move on to lesson 9, which was a lot about the more business side of it, and how to go about making a machine learning or AI model in a business. It goes through laws and regulations that you have to make sure that you're following, depending on the sort of data that you're using. It goes through making a security plan, making sure you know who technically owns the data and who is responsible for it, making sure They know who has access to the data, and how it can be secured, and again, any laws or regulations that you need to make sure that you follow, depending on the sort of data that you're using. Talked a bit about ethics, how to make sure that you aren't putting any things like preconceived notions or prejudice into your machine learning project, depending on the data that you're training it on. You want to make sure that certain things, like certain attributes of people, aren't being used in your model for analysis when it's something that doesn't really affect your project. If it is something that affects your project, it's okay to be in it, but things like race, gender, color, religion, national origin, marital status, and other things. It's good to make sure you stay away from them because your machine learning model can latch onto things like that and kind of make assumptions based off of those things when sometimes your model just isn't related to them at all. It also went through things like making sure that the data is being used for intended purposes. Sometimes you can find data that you don't mean to, or the data can be like used in a way that kind of harms the people it's affecting. Making sure that, harms the people that the data is from, and it's important to make sure that you're not doing that. It also goes over how to communicate the results, how to talk about it in a way that your audience will understand, how to explain everything, and just knowing who you're presenting to. It also talks about how to visualize your data in a way that your audience will easily understand. Like, make sure that it's readable like this, not like this, where it's harder to read. Effective ways to communicate your results. And then it talks about making sure that you have key performance indicators throughout your presentation, or however you're showing your results. And then I'm currently working through lesson 10. I haven't learned too much yet, but I'm having a couple issues with the course itself. I emailed the people in Pearson VUE to try to get some of the issues I'm having figured out. But yeah, that's how far I am through the course so far. I would show some of the labs, but they're not very hands-on. It's more of like a click-through sort of lab. But yeah, that's everything that I've been working on in my IT Specialist Artificial Intelligence course. I want to thank you so much for watching.